All right, next up, we're going to look at a couple properties to help us simplify some logarithms. So, some properties of logarithms, and we're going to talk about the properties of natural logarithms that are pretty much the same thing. If you have any log base whatever, sorry, there we go, it's less blurry now. Log base a of 1 equals 0 because a to the 0 equals 1. So, log base whatever of 1 equals 0. Log base a of a, so if those two values are the same, equals 1 because a to the first equals a. Now, if you have log base a of a to the x, that's equal to x. Now, one thing I want to rewrite with that is, so if you have log base a of a to the x, you're asking yourself, a to what power equals a to the x? Well, that's just x, so that's why it simplifies to just be x. The one right next to that's a little more complicated. Sorry, let me zoom out. A raised to the log base a of x also equals x. That one's a little more complicated. I'll see if I can explain that off to the side here. So if we have a to the log base a of x equals, well, let me just break that down a little bit. So I'm going to break down the log part here. So log base a to the x, let's say it equals some number b, which would mean, in turn, a to the b equals x. Well, okay, we just had log base a of x equals b. That means we can replace this guy with b. So we have a to the b. Well, we just also defined that as x. This is kind of like a circular reasoning. If that doesn't fully make sense to you, that's okay. But it's like you're substituting something back into itself. It's kind of goofy. But a raised to the log with the same base, a of x equals x. Last one, if log base a of x equals log base a of y, then the x and the y have to be equal to each other. That is the inverse, sorry, that's the one-to-one property. Now the log base e, natural log, has the same property. So natural log of 1 equals 0 because e to the 0 equals 1. Natural log of e equals 1 because e to the 1 equals e. And then the same properties that we had for the inverse properties and the one-to-one properties for logarithms. Natural log of e to the x equals x, and e to the natural log of x also equals x. And finally, natural log of x equals natural log of y, then x must be equal to y. So let's take a couple examples down here. Natural log of 1 over e. Now I'm going to rewrite that as natural log of 1 over e could also be written as e to the negative first. So using some properties that we have here, natural log of e to the negative first, we have to ask ourselves, e to what power gives us e to the negative first? Well, that's just negative 1. So e to the negative 1 equals e to the negative 1. So natural log of e to the negative 1 equals negative 1. Next up, number 2, e to the natural log of 5. Using that one-to-one property, I'm going to use the same explanation that I did before. Let's let b equal to the natural log of 5. We don't know what that is. So, based off of that, e to the b must be equal to 5. Okay, so if we said let natural log of, or b equal the natural log of 5, so we could replace that with e to the b. Well, we also figured out using that reasoning that e to the b equals 5. So e to the natural log of 5 equals 5. Looking at number 3, natural log of 1 over 3. Natural log of 1, that uses that first property. Natural log of 1 equals 0, so we end up with just 0 over 3, which is 0. Again, just to explain that one a little bit more, natural log of 1, if it helps you to write it as log base e of 1, you have to ask yourself, e to what power equals 1? And the only possible answer you could get is e to the 0 equals 1. So it's the exponent of that answer. Last one, number 4, log base 2 of x equals log base 2 of 4. This one, there's not a whole lot to it. X has to be equal to 4. So just boxing in my answers here.